We are live. Hi everybody. Welcome back to Geeks for Geeks practice. Today we'll be discussing another problem of the day. That was for yesterday, and the problem name is find last digit of a to the power b for very large number. So all of those who have joined, so just quickly give me a +1 in the chat and like the video if you haven't, so that we can begin ahead with the problem today. Just quickly comment down below how many of you were able to solve this problem, and if you were not able to solve this problem, what were the difficulties that you were facing while solving this problem, so that we can discuss about all those things, and I'll be telling you about my approach as well. So just if I'm audible to everyone and my screen is the question is also visible to all of you, then please consider giving a like to the video, and please give a +1 in the chat so that we can begin ahead with today's session. Okay. Okay, so I'll just wait for 1 or 2 minutes more for other people to join in, and then immediately we'll begin ahead with today's problem. How many of you were able to solve this problem? Just quickly comment down below. So talking about this problem, this was a easy problem. This was not more of a mathematical, this was more of a mathematical and implementation based problem, because in this problem what you have to do is you have been given you have been given a number a, and you have been given a number b, and in this what you have to do is you have to tell what is a to the power b, right? But what is the problem when you get such a question? So if you have to find a to the power b, then that is very much basic, right? You will say that if there is some time complexity issue, then you can do it using fast exponentiation in log b time, right? But that is not the issue here. The point with this question is that you need to find a to the power b for very large numbers. Let's suppose that a is also very large and b is also very large, right? What does that mean? So let's say that a is also 1000 and b is also 1000, right? Let's say if this is one of the cases, right? You have to find, for this question what you have to do is you have to find a to the power b, right? This is what you have to do. Now you'll say that this is very basic, you can do it using the power function or iterate, and it will take order of b time, right, to multiply all the powers, or you can do it using fast exponentiation, right? And you will say that you will do it in order of log b time, right? But that is not the issue here. This is not the issue here. The issue here is that the values of a and b are very large, right? Time complexity is not the issue in this problem, but the issue is that if a is somewhere between, let's say if a is between what? A is between 1 to 1000, right? And b is also between 1 to 1000, then in that case what will happen, right? In that case what will happen? Let me give you a short example. So let's say I do a 2 to the power 40, right? What will this be equal to? So let me just Google it so that we can see what it will give us. Power of 2 comma 40, what does it give? Let's check. Okay, 2 raised to the power 40, right? You can see that it will be a very large value, right? Let's see if we get an answer here. So you can see that 2 to the power 50, right? You can see 2 to the power 40 gives me this much value, right? This is quite large. How many digits? 1 2 3 4 5 6 7 8 9 10 11 12 13. So 2 to the power 40 has 13 digits, right? What I'm saying is 2 to the power 40 has 13 digits, right? So you have to find the last digit. In this question what you have to do is you have to find the last digit. But can you observe this, that this will not be possible? If 2 to the power 40, this is also very a small number, and this is the basic number, right? 2. If you take a value as, let's say, something 1000, and you take power 40, right? Do you see that it can be handled? No, it cannot be handled, right? It cannot be handled by integers or long or things like that, right? No such inbuilt system can handle it, right? Because long, or you can say long or int, nothing can handle such big numbers, right? Only, also notice that you have to print a to the power b, you have to only return the last digit of this particular exponent power, right? Whatever is the a to the power b, you only have to return the part that is a to the power b, right? That is the last digit of a to the power b. Is this much part clear to everyone? Is this much part clear to everyone? Just quickly give me a +1 if this much part is clear to everyone, right? Is it clear to everyone? Just quickly let me know if this much part is clear to everyone, right? Okay, now let us see what happens when we do a power, right? Let's say if the number, if I do something, let's say if I do something x to the power 1, right? What will it be? It will be x only, right? Or let's say I do 1 to the power something. Let's say I do 1 to the power x. In that case, what will happen? I can do anything and it will still be 1. But let's say I do 2 to the power 1, then it is 2. If I do 2 to the power 2, it will be 4. If I do 2 to the power 3, then this will be 8. If I do 2 to the power 4, it will be what? 16. Right? If I do 2 to the power 5, what will I get? I'll get what? I'll get 32. If I do 2 to the power 6, I'll get 64. If I do 2 to the power 7, I'll get 128. If I do 2 to the power 8, I'll get 256. Now what does this mean? If you notice, this is the last digit, here is 2, and let us see here also. At 2 to the power 5, the last digit is 2, right? It is repeating, right? It is repeating. 2 to the power 1 and 2 to the power 2. 2 to the power 2, 1 and 2 to the power 5, the last digits are repeating. Let us look at this example. If this is 2 to the power 2, this is the last digit is 4. If it is 2 to the power 6, then also the last digit is 4. If it is 2 to the power 3, the last digit is 8. If it is 2 to the power 7, then the last digit is 8. If this is 2 to the power 4, then it is 16. If it is 2 to the power 8, it is also 16. So notice that 2 to the power 1 and 2 to the power 5 are having the same. 2 to the power let's say 2 is having same as last digit as 2 to the power 6. 2 to the power 3 is having the same last digit as 2 to the power 7, and 2 to the power 4 is having the same last digit as 2 to the power 8. If you will do further, so you will observe that 2 to the power 9 is having same, 2 to the power 10 is having same with 2 to the power 2, 2 to the power 11 is having same, 2 to the power 12 is having same with these, right? So it is repeating after 4. Repeating after 4 powers, right? Repeating after 4 powers. Is this much part clear to everyone? Right, repeating after 4. If you can see the pattern 1, 5, then 9. Right, 2, 6 and 11. 3, 7 and 11. 2, 6 and 10. 4, 8 and 12. Right, this much part must be clear to everyone, right? Now the question comes that is this valid for everyone, right? So let us quickly have a look at the other test case, at the other numbers as well, and see, are we getting the same cycle everywhere or not? Because notice, you cannot do it using any other approach. You have to find a pattern for this. 3 to the power 1 gives me what? It gives me 3 to the power 1 gives me 3. 3 to the power 2 gives me 9. 3 to the power 3 gives me 27. 3 to the power 4 gives me 81. 3 to the power 5 gives me what? It gives me 243. Then 3 to the power 6 will give me what? I am not multiplying, but you can see that this is 3 to the power 5, the last digit is 3. So here also the last digit will be 3, right? 3 to the power 7 will give me what? It will give me something, but since this was 9, so I multiply another 3. So this will now become, if you haven't liked the video, all of you please like the video, because we are going to have a detailed discussion on the pattern of this problem, and then I'll be showing you how to implement it in the simplest way possible, right? So if 3 to the power 7 is there, then you last digit was 9, so you'll multiply here, so it will be 1, right? 3 to the power 8 will be what? It will be something, but the last digit will be 3. Everyone agrees on this, right? Notice that 3 to the power 1 and 3 to the power 5 are having the same last digit. 3 to the power 2 has last digit 9, and 3 to the power 6 also has the last digit 9. 3 to the power 3 has the last digit as 7, and 3 to the power 7 also has the last digit 7, right? This will be having the last digit as I'm sorry, I think that I did a mistake. Okay, so this will be 7, right? And this will be 1. Okay, right? So 3 to the power 3 is this last digit will be this, and 3 to the power 4 is having this, and this will be having this as well, right? So that means 3 to the power 1 is similar as 3 to the power 5, 3 to the power 2 is similar as 3 to the power 6, 3 to the power 3 is similar as 3 to the power of 7, and 3 to the power 4 is similar as 3 to the power 8. Here also you can observe that cycle repeats, or you can say that last digit repeats after 4, after an interval of 4, after a period of 4, right? Everyone agrees on this? Everyone is clear with this much part? I can see a lot of people are watching. Please consider giving a +1 in the chat, because we are trying to do a detailed discussion on this problem, right? So let's make some space and let's try to see further what will happen. Okay, what you will observe with the next let's take the next number and see what will happen in that case. If I do 4 to the power 1, it gives me 4. 4 to the power 2, it gives me 16. 4 to the power 3 gives me what? It gives me what? It gives me 64, right? 4 to the power 4, it gives me what? The last digit will be 6, and this will be 256, right? And if I do 4 to the power let's say 5, 4 to the power 5, then this will give me what? 4 to the power 5 will give me 4 to the power 5 will give me last digit as 4, because 6 into 4, the last digit will be 4. 4 to the power 6, let's say 4 to the power 6, so 4 to the power 6 gives me what? The last digit in this will be 6, right? Because 4 into 4 will be 6 last digit. 4 to the power, let's say we do 4 to the power 7, then the last digit will be 4, because 6 into 4 gives me 4, right? 4 to the power 8 gives me what? It gives me 4 into 4, 16, right? You can see that here also with an interval of 4, it is repeating, right? It is repeating, because 4 to the power 1 is the last digit is same as 4 to the power 5, 4 to the power 2 is same as 4 to the power 6, talking about the last digit. 4 to the power 3 is similar as 4 to the power 7. 4 to the power 4 is same as 4 to the power 8, right? So here also repetition after 4, right? After exponential 4, I am here repeating everything, right? Is this much part clear to everyone? Just quickly tell me in the chat. If this much part is clear to everyone, just quickly let me know in the chat, right? Let's take another number. Let's take another number for that matter. Let's take another number. Now I'll be taking another number, and let's say that number is 7, right? What does 7 to the power 1 gives me? It gives me 7. 7 to the power 2, what does it give me? It gives me 49. 7 to the power 3, what does it give me? It gives me, the last digit will be 1 here, okay? 7 nines are what? 63, right? So the last digit will be 3, something 3. 7 to the power 4 will give me what? It will give me the last digit. 7 4s are 24. What will happen? What will happen in this case? Can someone tell me? Someone can tell me? Right, so 7, so this digit will be 1, right? So now you'll observe again that 7 to the power 5 will give me what? 1 into 7, the last digit will become now 7, right? 7 to the power of 6 gives me 7 sevens are 49, so the last digit will be 9. 7 to the power 7 will give me what? 9 into 7, so that will give me 3 as the last digit, right? Is this much part clear to everyone? For this particular case, is this much part clear to everyone, right? So I am seeing a repetition after an interval of 4, right? Is this much part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Right. Okay, perfect. So what I can say is, if you similarly you can try for other numbers like 9 also, 9 then 81, and then it will also be repeating, right? This much part must be clear to everyone, I think, right? This was very basic and intuitive part. Now the question comes that, okay, you'll say that is fine, perfect, but how do we know it, right? Let me take a test case. If I'm taking 3 to the power 10, so in this case what will happen? Let's say I'm taking 3 to the power 10. Okay, if I'm taking 3 to the power 10, so in that case I am saying that it repeats after 4, right? So can I say that my A is 3 and my B is nothing but 10? So now let's update our b. So b will be b mod 4, that is 10 mod 4, because the cycle, notice that the cycle is repeating after 4. So that simply indicates that now this will be what? This will be 2. So now my b is 2, right? So this will be nothing but 3 to the power 2. Notice that I am taking here only the last digit, but here only one digit is present, right? 3 to the power 2 gives me 9, and let's see the answer. The answer is also 9, right? Everyone agrees on this, and we did not have to calculate it in the bigger manner, right? Everyone will agree to this. Does everyone agrees to this part? Quickly give a +1 in the chat if everyone. Okay, perfect. It is clear to everyone, right? So that is good, right? Now you will say that let's say that we have a number. Now you'll say that perfect. We can solve it using taking the mod, but there is a catch in this problem. Now let's say I have 3 to the power 4. Now you'll say that a, or say 13 to the power 4. So you'll say that a is equal to 13 and my b is equal to 4, right? You will say this, but what is the situation here? Let's try and analyze it. What's the situation here? You will say that let's do b is equal to b mod 4, and now 4 mod 4 equals to 0, right? This is what you will say. This is what you will say. Is this correct? Is b equal to 0? Now should you be doing this? Should you do this? Should you do this for this one? Yes or no? Is this right? If it is right, write yes in the chat. If it is not right, then write no in the chat. Is this thing correct? Is this thing correct or not? Just quickly let me know in the chat. Quickly let me know in the chat if this is correct. If this is correct, then write yes. If this is not correct, then write no. What's your approach? Okay, no. Why? What's the reason? With the reason. You have to write it with the reason. What's the reason for that? Right. What's the reason for that? Because we are saying that the cycle is repeating after 4, right? The cycle is repeating after an interval of 4, right? So what we are saying is that let's suppose that even if this was let's say 3 only, right? If this was 3 to the power 4 only, right? So what will happen in this case? You will do 3 to the power 0 and it will become 1, whereas actually in this case it is also exception, right? Let's say I take a number which is another repeating number. Let's say I take 2 to the power 4, right? So my a will be what? A will be 2. Let's do this. So you will say that this will be 2 to the power 0 because my b will become 0, but this comes out to, last digit comes out to be 1. But whereas the actual 2 to the power 4 will give me what? 2 into 2 into 2 into 2. So that gives me 4. 4 to the 8, 8 to the 16, right? So here actually the last digit should have been 16. So if it happens that your 4 mod 4 or if your b mod 4 is equal to 0, if your b mod 4 is equal to 0, then in that case you will mark your b as 4. You will make your b as 4 only, right? It will remain as 4, right? Is this much part clear to everyone? Is this much part clear to everyone? Just quickly let me know in the chat. Is this much part clear to everyone? Only then I'll be proceeding ahead. Is this much part clear to everyone? Just quickly let me know. Is this much part clear to everyone? Everyone is clear with this much part? Okay, perfect, right? I think that this much part must be clear to everybody. Okay, now the question comes that both a and b, both of them have been given to us in form of a string. Notice that both have been given to us in form of a string. Can I say that for this I only want the last digit? I only want the last digit of this string, right? I want only the last digit, or you can say the last character for this, right? Can I say this? Yes, I can say this. But can I say it for this? No. I need to convert this b string shall be converted to an integer, right? Everyone will agree to this, that this b string should be converted to an integer. If I am giving a string as b as 13, then I have to convert it as an integer, right? Everyone would agree to this, right? Does everyone agree to this? I'll make it as 13. I'll have to make it as 13, the number, because notice that b is between 1 to 1000. So that is why we can afford to do that. We can afford to change it to the number, right? Everyone will agree to this, right? You have to convert this b into a number, only then you can find the power, right? For this string you can find the last digit, right? You can say simply what you can do, you can say that if this is a string, then you can say that a dot back, you can say it like that, or you can say s of s dot size of, or you can say a of a dot size minus 1, right? You can say this. For extracting the last character, you can do a of a dot size minus 1. This will give me the last digit, right? And I can simply subtract it by 0, right? How do I get the last digit? Let's make some space again. For the number a, what I can do is a will be becoming a dot size minus 1. This will give me the last character, right? This gives me the last character. Now what I'll do is I'll subtract it with a string 0. So suppose that I have got a character, let's say 2 as last character. After that, if I am subtracting it by 0, so the answer will come out to be 2, right? So now I'll get this 2, right? Similarly, if I am getting a 3 and I subtract it with a 0, character 0, then I'll be getting 3. Everyone will agree to this, right? 9 minus this 0 gives me a 0. The ASCII values are getting subtracted, but you are getting the answer that you want. That is the last digit of a. Everyone is clear with this much part? Is everyone clear with this much part? Just quickly let me know in the chat. You can use STOI also, no problem. You can use that as well, I think. Okay, right. So what you have to do is, you have to find, for a, you have to find the last digit, right? And you can find it, right? As I told you. For b, you have to convert from string to int, right? This is what you have to do. After that, what you have to do is you have to find b mod 4, and if b mod 4 is equal to 0, then b will be equal to 4, else b will be equal to b mod 4. Everyone is clear with this part? Everyone agrees to me on this part? Just quickly let me know. Please. Quickly let me know for this much part. Is everyone clear with this much part? Right, everyone agrees with me on this part. If b mod 4 is 0, then b is equal to 4, otherwise b is equal to b mod 4, whatever is the number, right? You can convert b to integer in any way. You can iterate, or you can do it using STOI, anything, okay? Right, this much part is clear? Perfect. Right, so now shall we move to the coding part, right? Shall we move to the code part? Let's move to the code part. Let me show you. First of all, let me show you that the answer is getting accepted. Okay. So yeah, you can see that this answer got accepted in the best time possible, right? Now let me show you the code part that I have written for this problem. Now there were some edge cases as well, right? What were these edge cases? We haven't discussed about them, but let's discuss them here, right? What I'm saying is, if my a dot size is 1, right? If only one digit is there and that digit is 0, if only one digit is there and that digit is 0, right? If only one digit is there and that digit is 0, and if in my power also, in my exponent part b, if only one digit is there and I have 0, so if I have to calculate 0 to the power 0, it will be 1. I'll return 1. Everyone will agree to this. These are some of the edge cases that you need to take care of, right? And if what is happening, if I have 0 and I have 0 to the power b, right? If I have this number, if I have anything, let's say 0 to the power b, and b can be anything between 1 to 1000, right? It will always give me 1. Everyone will agree to this, right? I have to return 1 for this, right? Everyone will agree to this part, right? This much part is also clear, right? Now let's see another edge case for this problem that can happen. If my b dot size is 1, if the power that I am going to do, if it is 1 and it is 0, right? If it is 0, then in that case also I will be returning 1. Why? Because another case, if a to the power something that, let's say b is 0, right? What I am claiming is b is 0. So if that is the case, if any number, a can be any number between 1 to 1000, right? 1 to 1000, the last digit would always come out to be 1. Everyone agrees to this part as well? Does everyone agrees to this part? Everyone is clear with this part as well? Anything to the power 0 will give me 1 only, right? So if the power part, if b part is 0, so that means a to the power b will become what? 1, right? Irrespective of the fact that whatever a is, right? Everyone will agree to this as well. Now let us see. So another thing that you need to do is that these are the three edge cases. If you have 0 to the power 0, then in that case you will return 1. Also, if you have 0 to the power something, sorry, I just mismanaged it, 1 second. So I was saying that if 0 to the power 0, if you are doing 0 to the power anything, so it will be 0, right? 0 to the power anything is 0, right? This is what I was saying. Okay, sorry for the mistake. 0 to the power anything will give me 0, right? 0, I just didn't notice that I'm making a mistake. So if I am doing 0 to the power anything, so it will always be 0, so the last digit will be 0. That is why for the second part I am returning 0, right? Everyone will agree to this. I'm returning 1 if it is 0 to the power 0. If it is 0 to the power anything, I'll return 0. And if it is b dot size is equal 1, and if it is something to the power 0, then again I'll be returning 1. Everyone would agree to this as well. After that, what I'll do, this is my last digit. Num a gives me the last digit. Num a will give me the last digit of the particular number a that I want to find the exponent for, right? If you haven't liked the video, please consider liking the video as well, right? This is what I'll do. Now what I'll do is I'll convert b to an integer, right? In this function, what I am doing is, in this function below, what I am doing is I am converting string b to an integer, right? In this function I am doing that, converting string b to an integer b, right? I'm converting string b to an integer. What I'm doing is I'm iterating from the start, and simply as you do for finding the digits or multiplying, you must have done the reverse digit or things like that in basic numbers. So that is what I'm doing. Num b is equal to, num b is what? Num b is the actual string b in integer, right? After that, what I'll do, num b is equal to num b cross 10 plus the current digit minus 0, so that will give me the current digit, and I'll keep on taking mod by 4, right? This is what I am doing. You can take at the last as well, there is no problem with that, but the reason why I am doing this is so that let's say if the number was very large, so in that case I only want the last digit, so that is why I can always take the mod here as well. Is this much part clear to everyone? After that, if my num b is equal to 0, so if I am getting num b as 0, so that means that it was divisible by 4, so in that case it should be equal to 4. That is what we have discussed as an edge case, right? We might have made the mistake because the cycle is starting from 1 2 3 4, and after that it is repeating. So if it was 8, then it should be 4. If it is 12, then it should be 4. If it is anything divisible by 4, then it should be 4, right? Everyone will agree to this as well, right? After that, you simply use the power function and you return num a, which is my last digit, that is a to the power b you have to calculate. So num a is my last digit of a, and num b is the power between 1 to 2, right? Okay, let me check what you are saying. Both of them are lying between this. Okay, yeah, right, you are also correct. You are also correct on your part, but you have to only return the last digit. You have to only return the last digit, right? You only have to return the last digit irrespective of the fact that you are taking a mod or not. Okay, right? So you will be calculating the power, and in that way you will simply be returning result mod 10. Why result mod 10? Because whatever you get, let's say you get 81, so you have to return only the last digit. That is why you will do it mod 10, right? Is this much part clear to everyone? Is the question clear to everyone? Just quickly let me know. You can take a screenshot of this and you can try to do it a dry run for any case. Okay, is this problem clear to everyone? Just quickly let me know in the chat. Is it clear to everyone? Just quickly let me know in the chat. Is this part clear to everyone? Is this problem clear to everyone? Just quickly let me know in the chat. Write a +1 or clear, or like the video if you haven't. Is this problem clear to everyone? Is this problem clear to everyone? Just quickly let me know. Is this problem clear to everyone? Just let me know. Is this problem, if it is clear to everyone, please write a +1. Okay, perfect. What about others? Just quickly let me know. Is this problem clear to everyone else? Is it? Okay, perfect. So this was the problem of the day for today. This was the problem of the day for today. I hope all of you have understood it. In case if anyone is having any doubt, so they can mention it in the comments and I will reply back to your doubt as soon as possible. Or if you had any other approach for any particular segment of the code, so you can share that approach with us in the comments as well, so that the community can get help from that. Apart from this, one thing that I want to tell you is that I'm also teaching on a channel that is named as Code Era, and there we are covering a lot of things. Like we are covering mastering game theory, Code Forces game theory series. We are also covering Code Forces educational round and other things as well. So you can consider subscribing this channel if you want to learn something about competitive programming or other things. We are covering at coder and at coder concepts. We are covering it topic wise as well. There mastering theory, mastering game theory or mastering grade D series. We have had 2 series as well up till now. So you can consider subscribing this channel if you want to accelerate your learning process in competitive programming. And talking about this, so the last things, that always try to solve the problem of the day each and every day. And what you should be, the problem of the day for today is find the duplicate. Also this problem was asked in Samsung, right? This problem that we discussed, last digit of a to the power b, it was discussed in the company like Samsung, right? So today the problem of the day will be find duplicate rows in binary matrix, and this problem has been asked previously in Microsoft, in a company like Microsoft. So make sure to solve this problem of the day today. There are 8 hours remaining for this problem. If you will solve these problems, so you must have seen a lot of people are posting about getting a t-shirt or things like these. So you will get a lot of goodies from Geeks for Geeks if you are able to solve these problems, right? Each day you will be getting 1 geek coin. So make sure to solve it and subscribe the channel if you haven't already. So that was it from my side. If anyone is having any sort of doubt, so you can mention that in the comments and I'll be looking into your doubts. So thanks a lot everyone for watching, and I'll see you soon.